Oh, look at that. We're getting some data. Hi everyone, welcome. So before we begin, please check this Slido out and answer 2 simple questions about your demographics so we can see who's here and who's tuning in. I'm gonna give about 2 more minutes for people to hop in. So if you are just tuning in, please follow this QR code to the Slido side and answer 2 simple questions about your demographics. So we can see who's here tuning in, joining on the conversation. Yeah, it is all, let's see here. Yeah, is also in the chat. You can see the, if you can't access through the QR code, you can click the link in the chat. You can do it, and in 1 minute, we will begin the program for tonight. So there we have it. All right, very interesting. Could we take a look at the data one last time? Let's see who won here. It's always interesting to see. It's never what you expect, actually. There we go. Okay, so about half the participants are from the business side. Very interesting. And the age groups, how'd that look? I think I saw that at 21-30. Yes, there we go. Very nice, very nice. All right, I will start the sharing here. And can someone from the moderator team just confirm that you can see the slides here?
Yes, we can.
Very good, very good. Warm welcome everyone to this event by Stockholm AI. My name is Ali. I'm a member of the board here. We have a very exciting program for you tonight. And before we begin, I know that we have some newcomers to Stockholm AI and to our event. So we'll do a quick introduction of the organization, and then we'll get right started. And also, before we begin, I just want to highlight that after our speakers have spoken, we will have time for some Q&A. So please, again, you can go into that same page where you just answered demographic questions. You can ask your questions to the speakers, and yeah, we will do our best to ask them to our speakers afterwards. And we will see at the end of the program, maybe if there is very high engagement and the speakers are kindly, if they have time for us, then we can have like a sort of extended Q&A afterwards. We will see. Okay, so again, welcome to Stockholm AI. We are a group who started in 2017 I wasn't there actually, but rumors are there was a couple of friends, enthusiasts, who found this field to be extremely interesting, and inspired by other cities groups. You have Paris AI, Montreal AI. We started Stockholm AI, and the purpose is to really gather everyone who has an interest in this, whether you're from the business side or from the technical side, in a common place, and discuss and share knowledge and share experiences. AI is not a simple field. We have many subfields, so of course we need inputs from everyone, really. Right now, if you look at our Facebook, that's of course not the best metric for engagement, but we can see that we have over 3,500 members, which is very nice. Okay, and our goal is really to establish Stockholm as a global player within this field. We know that internationally speaking, Stockholm is spoken as the unicorn, world's second largest innovative hub after, I think, Silicon Valley. So we're basically Europe's Silicon Valley, and we want to help keep that up by establishing contacts with industry, with academia, and everyone really in our area, not only in Stockholm, but actually in Sweden overall, and make sure that we can share experiences and knowledge, and make Stockholm a leading AI and ML hub for Europe. So, and what do we do then? We have many different types of events. One of them is in this format, so-called meetups, where we invite leading speakers, experts in a field, and they get to talk about their experiences and what they're doing. It can be, again, from a business perspective, also very technical. And then we have other events. We have, for example, distilling AIs, where we pick a topic and we ransack that topic. We go in and delve into it deeply and really talk about it. And this is very interesting. Like, even if you're coming from a technical side of things and we pick a topic such as regularization, that might seem trivial at first, but it's really not. I learned a lot, actually. And I have a very heavy mathematical background. It's not all about the gradient descent and the backpropagation, these sort of things. There's so much more to it. So very, very interesting. Distilling AI, as we said, we have pizza hangouts where we just hang. We want to be a networking hub for our members, which I think we made a polling about this, and what we can see is our demographic consists of 50% professionals, 20% researchers, 15% students, I think, and 12% hobbyists, and 3% other. I'm not sure what that other is. It's very interesting, but they said other, so there we go. So it's very, very varied here, actually. So it's very nice. Okay. And also, of course, we want to thank our sponsors, Ericsson, for helping setting this up tonight. Very grateful for enabling our events. And here we go. This summit tonight is on AI ethics. You've all heard about this before. It's a very important topic. There's been a lot of buzz about this. Started about 2 or 3 years ago. It was kind of diffuse. A lot have happened since then. So hopefully tonight we'll get much better grasp on that. And with us, we have industry leading and academic leaders on this topic. Fredrik Heintz, member of the high-level expert group in the EU. Josefin Rosén from SAS Institute, actually voted as the AI ethics professional of the year, which is very nice. And of course, a quartet from Ericsson, very qualified people who will tell us a little bit more on the theoretical side of it, I think. And this is the program. We're not done with the introduction. We're gonna start off with Fredrik Heintz, who's gonna talk a little bit more about AI regulation and impact. As I said, he was a member of the he's a member of the high-level expert group in artificial intelligence for European Parliament, and they released, among others things, the ethical guidelines for Trustworthy AI. This was a couple of years ago, so it's going to be very interesting to see what has happened since then. So I think we will begin there. Fredrik, if you are ready, yeah, let's all give a digital very warm welcome to Fredrik, and the stage is yours.
Thank you very much, Ali. So it's a great pleasure to be here. So let me see. Yes. So as Ali said, my name is Fredrik Heintz, and I'm a professor of computer science at Linköping University. And I'm an AI researcher since about 20 years back. As Ali also mentioned, I've been part of this high-level expert group that the European Commission put together as one of its initiatives towards developing its AI strategy. Today, I also lead one of the 4 AI research excellence center networks in Europe, the one called TAILOR, where we are developing the scientific foundations for trustworthy AI through the integration of learning, optimization, and reasoning. I am also very much involved in a large number of other activities. So what I wanted to do here is kind of give you the big picture and also highlight some of the challenges and some of the ways forward towards this. And I really think it's really important to start with this, that Europe is very much interested in, and I have made it very clear that, yes, we do want AI, but we do not want any AI. So it's been very clear that we want to find a European approach towards AI. And it's also very clear that we're not really interested in running other people's races, but rather to build on the strength and values of Europe, which I actually think is a very sound and good starting point. So therefore, we have taken the stance that, yes, we do want AI, but we want this human-centric approach, which means that AI should not be developed for the sake of AI, but rather AI should be developed as a means towards making our lives better as citizens and people working and living in Europe, and of course the rest of the world as well. And secondly, we want our AI systems to be worthy of trust or trustworthy. And in this high-level expert group, we were tasked with defining or developing these ethical guidelines for trustworthy AI. So what we did was that we started out by saying that in order for a system to be trustworthy, there are 3 criteria that needs to be satisfied. First of all, these systems need to be lawful in the sense that they need to follow the applicable rules and regulations, which actually is not as easy as it may sound. I mean, an interesting example is, of course, self-driving cars. And if you are in a situation where there is a risk of an accident, and if you violate a traffic rule, you might increase the likelihood, or sort of decrease the likelihood of an accident. And now the question is, should you break the law in order to reduce the risk? Or is it more important to follow the law, even if that may cause or lead to an accident? But of course, in most cases, this is definitely what we want. The second is that they should also be ethical in the sense that they should satisfy a number of ethical principles. We have defined 4 such ethical principles. And third, and actually in a sense, I think this is the most important one, namely that it's not sufficient to have good intentions. You also have to build robust and safe and sound implementations of these systems. So they really need to be robust in a broad sense. And I mean, there are many companies and organizations that have put forth similar kind of ethical guidelines. So what I think is really the hard problem, the really difficult problem is to how do we actually operationalize this? How do we come to such a level of detail that we can actually start implementing, monitoring and enforcing these kind of regulations? And so I'm very much interested in the talk after this, which seems to be much more on the operational side of things. But what we did was that we had these kind of general principles. We then defined a set of requirements, which can then be used by the software developers towards realizing these systems. And thirdly, we also developed an assessment list, basically a set of questions that you can ask yourself or your company can ask in order to determine whether your system is trustworthy or not. So we actually took a number of steps. So the 4 principles that we defined are all based on the fundamental human rights. That was our starting point. So the 4 principles are respect for human autonomy. So this really means that these systems should augment, complement, and empower people rather than the opposite. And here I think there are some very interesting, again, cases, for example, when it comes to, say, nudging. So many of you might be using apps such as that help you eat healthier or exercise more. And I mean, then you have configured these systems in order to try to push you in a more healthy direction. And this is probably quite unproblematic because you can always turn it off, you can ignore it, and so on and so forth. However, now we can consider the case where your insurance agency says that, if you install this app and follow the recommendations, we will reduce your premium with 10%. Now it starts to become a bit questionable. And now you might take the step that now our country, for example, might say, we want to increase the level of health in our country. So therefore everyone needs to use these apps in order to push people in a more healthy direction. Now I think it becomes even more questionable. So I really think there are some very interesting questions here regarding this respect for human autonomy. And in some sense, it's about allowing people to make mistakes and to make things, even though they might not necessarily be in their best interest in a kind of longer and wider term. But still, it's important that we have this ability. Second is actually, I think, the least controversial in a sense that no one wants these systems to do any harm. So prevention of harm is, of course, very natural. So that means that they should be safe, secure, and protect both the physical and the mental integrity of the users and people in general. The third is fairness. So again, this is something which is very easy to state. Of course, we want our systems to be fair, meaning that there should be equal and just distribution of both the benefits and the costs. However, when you start to try to operationalize this, then it becomes not as apparent anymore. And of course, the 2 very important distinctions here should be fair allocation of resources, meaning that everyone should get an equal amount of something, some limited resource, or should it be fairness in the outcome. So you want the same outcome for everyone in the population, which might then require different amounts of resources for different people, depending on their circumstances. And actually we can directly connect this back to, say, for example, this debate in Sweden about the school system, where each student in school has the same amount of money. They have this fixed amount of money per person, but at the same time, of course, the different students will need different amounts of help and support in order to reach the goals that we have put forward for schools. So in some sense, we're having fair allocation of resources, but we also expect the outcome to be the same. So, and of course, there are many other interesting challenges when it comes to defining what fairness really means. The fourth and final principle here is explicability, which is all about understanding how these systems work, on whose behalf they're working. So it's about transparency and being open with capabilities and purposes. And this question of explainability, which I saw in the agenda, we will hear more about later, which again, I think is one of these concepts which to a large degree sound very obvious, but if you start poking on it, it's no longer that obvious exactly what does it mean and how to realize it or how to evaluate it. What is a good explanation? So taken together, I think these form a very good foundation. I think it's also clear that all of these principles are to a high degree unsolved problems. And I would argue that some are probably, I mean, not really solvable, but that's a continued dialogue around in a society what we mean with things like fairness, which I do think is more a social agreement than a technical term. Here we see that there are a lot of interesting research challenges, often involving multiple competences. So this is not purely technical problem, and they also, of course, are not completely non-technical problem, but how can we get the technology and the kind of social sciences and the philosophy and all these other relevant subjects to work together, which I think is super interesting. And now I think it also leads to these very interesting questions. How should we evaluate AI systems? I mean, the classical example here, or I'm not sure it's a classical example, but at least the example I often use is this example from AlphaGo, and in this famous games against the KG a number of years back, and where there was this game, or actually a particular move in one of the games, where all the expert commentators basically say that, oh no, the computer made a mistake. I mean, a human would never play like that. And of course, you all know what happened, namely that the computer won. So it's very clear that this was an objectively good move. If you just look at the kind of rules of the game and the outcome. However, from a human perspective, when we judged, or the experts judged this move, it looked like a terrible move. So the consequence here is, of course, I mean, this is a Go game. So the kind of consequences of making a bad decision here are not particularly severe. But now we could imagine that instead of this being a kind of recreational game, assume now this is a recommendation system helping a medical doctor. And the medical doctor gets a recommendation from the system, which this medical doctor, I mean, based on his or her knowledge and experience, this doesn't make any sense whatsoever. But how should that person know whether this is objectively good or bad? Because you could imagine, I mean, both the situations where the doctor actually follows the recommendation and it turns out to be bad advice, and you might have potentially catastrophic consequences. But you could also think about the opposite, namely that the doctor does not follow the recommendation and it turns out that this recommendation actually was a good one. And here I think we have a really interesting challenge in how should we evaluate, how should we try to judge what these systems do? Is it good, or is it potentially bad? And of course, here things like this with explainability and so on comes in as one part of this solution, or addressing this challenge. I think another very interesting challenge is this: how will we cope with the outcomes? Because I mean, my expectation here is that when we start to analyze the way that we humans make decisions, we will come to the conclusions that we're probably not that particularly good at making decisions. And the concrete example I use here is the French legal system, where they, a number of years back, made basically all the court cases available digitally. And of course, researchers starting to study the decisions made by judges. And I think the particular case that they were looking at was some asylum cases. And they basically came to the conclusion that the outcome of a court case was more dependent on which judge you got, rather than the actual circumstances in the particular case. Which, of course, I mean, the consequence of that is that these judges are biased in different directions. But what's interesting, I mean, to me, that was not particularly surprising. I mean, I expect most human decision making to be biased in many different directions. But rather, what was the reaction from the kind of legal system on this? Well, they weren't too happy. Instead, they put a ban on doing this type of analysis of independent or individual judges' decisions. So rather than taking this information, basically an external perspective on their own decision-making and learning from it and see how can we improve our human decision-making, they rather said, no, you're not allowed to do this. This is illegal. And now you can go to prison if you start to analyze judges' decisions. And I really think we will see this in many different circumstances, that we might, in some cases, overestimate our own how good we are at making decisions. And my personal view here is that we should really learn from this, take this as an opportunity to get this external perspective and use that to help us make even better decisions in the future. So that was the work that we did a few years back. So what is the current situation when it comes to the kind of legal system and so on? So first of all, there was this white paper presented by the European Commission and let's see, in 2020, in the spring of 2020, and then in this right around summer last year, the Commission came with its proposal for an AI Act, which actually is the first attempt to regulate the use of AI. And there they took a risk-based approach, meaning that they basically define the rules, the regulatory, the regulations that are applicable based on how risky a certain approach or application is. And they had 4 categories, where the top level category here is about unacceptable risks, meaning things that should be completely prohibited. And examples of this are, for example, subliminal manipulation of decisions or subliminal manipulation. And another one is this remote biometric identification. For example, that using facial recognition in large scales and try using that to identify individuals. There's also one about social scoring as a third example. So the idea here is that certain things are so risky that they're completely unacceptable. Then maybe the most interesting category is the high risk category, where there are applications which have the effect or the potential of impacting humans to a large degree. And here we have basically everything that involves recruitment, medical situation, and other decisions which influence people's lives and well-being. And here there are quite severe, a lot of regulation would be applied to these cases. And they have to be subject to compliance ex ante. So basically, before they have to show this before the launch these applications. And then the expectation is that these types of high risk and unacceptable risks are in some sense a relatively rare case. And most of the applications that are being used, for example, in industry and business to business and so on, should be minimal or no risk, which can then be permitted without any real restrictions. So the idea behind this is, of course, that the amount of regulation should be proportional to the risk. I think from my perspective, I think what the challenges here would be twofold. First of all, I think it will be very difficult to draw these lines between these different risk categories. Secondly, I think probably even if it's relatively clear, I think still many companies probably would not dare to risk making an error here. So they probably might be tempted to push it to a higher risk category than they might be absolutely necessary. Of course, there's also the risk that you can basically redefine the way you approach a problem so that it doesn't count as AI at all. And actually, that's one thing I haven't really brought up here, but there is a kind of a major discussion around how should one define what AI really is. And there have been a number of different definitions proposed, and none of them are really great. And I mean, in my opinion, it's very obvious because AI is not a very uniform thing, but a very diverse set of techniques and a diverse set of applications. And I really think it would be very difficult, if not impossible, to come up with a really good and still discriminatory definition, meaning that it actually encapsulates the set of things that you want in a relatively nice way. So my expectation here is that a lot more will be counted as high risk than might be actually necessary. So what assuming that your application now counts as high risk, what do you need to do? So here you need to establish and implement a risk management system, and it has to be in line with the intended purpose of the system. So for example, you have to use high quality training, validation, and testing data. So actually here the regulation was very strong in the first language. It basically said that your set of training data has to be complete and without error. And all of us who has been working with this know that those kind of data sets only exist in the very trivial and probably quite uninteresting cases. So here I think the language will be changed, but there will be very tough requirements on the quality of the training set, that they are representative for the populations, and also the quality of the content of these training sets. Then there is also need to have technical documentation and a lot of logging capabilities, so that if something happens, that at a later stage something needs to be you need to audit it, then there should be this traceability. So you should be able to trace all the different steps that were taken, and kind of who did what, and so on and so forth. And you also need to ensure an appropriate degree of transparency, and that the user should have information about the capabilities and also the limitations of the system and how to use it. And you have to also ensure human oversight, which means that there should always be this kind of opportunity or option for human intervention and human introspection of these systems. And of course, this robustness, accuracy, and cybersecurity. So actually there is a lot of demands on these systems if you're and if you're counted as a high risk. So I see that my time is almost up, but as I said, we also have this assessment list, so basically a set of questions to address that you can ask yourself in order to convince yourself that you're actually satisfying these principles. And since there's quite a close connection, I think these are still applicable. So now, of course, the interesting question is how to address these challenges. And I really think one needs to think about systems not as kind of either AI or either humans, but rather it is humans and AI, that we kind of combine the strength of both AIs and humans. I also think we will need massive efforts in education, and that we need to broaden this education to a much broader set of people. And finally, I think no individual company or organization can address these challenges on their own. We really need to work and help each other out in ecosystems. And of course, I also think we really need to combine this more data-driven machine learning types of techniques, which can correspond to the kind of fast human system, but also this more formal, logical, with explicit guarantees and explicit kind of explainability and so on and so forth, that can characterize as this more slow part of the kind of human decision making. And of course, we need to combine these to take advantage of both types of methods. And I mean, I think also when thinking about forward looking here, I really think we need to move away from these correlation-based methods, which is kind of the standard, towards more causality-based models, where you can also understand basically what do I need to change in order to have a certain end effect. And then if we can combine these more data-driven and knowledge-driven approaches, then we can use these causal models to both explain what happened in the past, but also to predict what may happen in the future. And I really think that from a Swedish perspective, we're starting to get a really nice AI innovation competence and research ecosystem, ranging from basic research to helping organizations accelerate the use of AI through AI Sweden, for example, and that we're also connecting much more to the European AI ecosystem. And I see that more and more Swedish companies and organizations take a bigger role here. And I really think we need to be more involved in this European ecosystem. And as I said, I'm leading one of these 4 networks, and we're really about developing the scientific foundations for trustworthy AI. So to conclude, I really think that this building this trustworthy AI system is absolutely essential. You as a company, you as an organization really need to gain and retain the trust of the users. And this system should then be legal, ethical, and robust. And I mean, there are many initiatives, but I would say there's still a lot more challenges here to be solved, both from the kind of research perspective, but also from the practical operational perspective. And I really think the way forward is that we need to work together in order to address these really challenging problems. Thank you very much.
And thank you, Fredrik. That was very, very interesting. This topic, AI ethics, I think this was a start of the broader mass of the population getting more involved and conscious about this technology, because it suddenly got much more relatable to them. They've seen examples on the internet and social media, in particular, what can happen with this application and where it can go wrong. So there's a lot of talks, and not just among technical experts, but other people as well. So yeah, it's a very hot field, and I can tell you, Fredrik, you're very popular. You've got a lot of questions.
I'm sure.
But we only have time for one right now. Maybe afterwards we can stay and take it. So I'll give you this one. If you read the ethical guidelines for trustworthy AI, which was released 2019, I think. Yeah, it's sort of the assessment list is sort of like a yeah, step by step. This is how you do. But your group has been very, very clear in that list is non-exhaustive. And during this talk, I've noticed you said, yes, this is a good foundation, but the problems that are being tackled, there are pretty much unsolved problems because it's very context specific. It's difficult, right? It's not just about tech. Tech has to combine with non-tech, and then you have to bring sort of, yeah, it's complicated. So an interesting question to that is, again, these guidelines and others started popping up from 2019 and onwards. But do you have a feeling of how companies are, to what extent they are approaching this and, you know, applying them to their own organizations? Or is it still just an academic exercise and we have not, you know, reached the applied phase yet?
So I mean, as I expect from the talks following me, I think we'll see a lot of the practical applications of this. So I should say that, I mean, this assessment list was not something we just pulled out of a hat, but rather there was actually quite an extensive set of pilot studies done with real companies and real organizations. Actually, it was led by Umeå University and Virginia Dignam. So they had a lot of interviews and they collected this. So we did a first iteration and that was, I think, had like 131 questions, which no one ever had the time to do. So in the second version, after we had further refined it together with this external people, then we had a much more trimmed set of questions. But today I would say there's a lot of discussions about standardization. So it seems like a lot of people, or I would say a lot of companies are actually pushing this, that the way forward here is to kind of codify or to kind of agree upon what is the kind of a good enough approach to deal with these questions, and then can we kind of agree about how to package this, and then we standardize this, and then we know that we have something to work on. So I would say that, I mean, the last actually 3 years or 2.5, there's been a lot of work in actually operationalize this, and I mean, I think we're both seeing this kind of trying things out in practice, but also the kind of legal trend trying to capture these things in a more formal framework. And it will be very interesting to see how these two converge moving forward.
Indeed. Thank you very much, Fredrik. And hopefully you can stay afterwards for some more. Okay, so that was extremely interesting. Fredrik gave us a background about AI regulation impact in a European perspective, what's been going on there. And to follow up on that, we have no one other than Josefin Rosén. She works currently at SAS Institute. And as we previously mentioned, she actually was elected the AI Ethics Professional of the Year for last year. And the first time I met Josefin was during a talk also a couple of years ago before the pandemic hit. she was talking about this AI ethics topic, and what I noticed, there were a lot of speakers that day, but when Josefin came on stage, there was a sudden change in the mood. You know, she has this pedagogical way of speaking. You know, she's very patient, she's very knowledgeable. So it's a pleasure to having her here with us today to talk about operationalizing responsible AI. So with that, the stage is yours, Josefin.
Thank you so much. I'm going to try to live up to that. Let me first share my screen. I'm stealing it now from Fredrik. I hope you can see it right now.
Yes.
Yep.
Yes.
Good. Thank you. And thank you, Fredrik, for a very, very interesting presentation. It's great listening to that. And thank you for having me. My name is Josefin Rosén, and I am leading the Nordic AI and Analytics team at SAS Institute. So many organizations that we are working with are now moving on from years of playing around with smaller, isolated AI projects towards serious efforts to scale and operationalize AI. And it's one of the key missions, I would say, of my team to coach them how to do this in a responsible manner, to help them to address the right questions, and in real practice, help them to put responsible, trustworthy AI into action. And that is also what I want to talk about today. AI is across just about every industry, more and more often involved in decision-making, and decisions that can have a large impact on the individual, decisions about things that can entirely change the direction of someone's life, potentially in a negative direction. So with that said, it is of course more important than it ever has been to make sure that we are deploying AI that is responsible, transparent, and trustworthy. Peter Parker's Uncle Ben put it very nicely when he said, "With great power comes great responsibility." But as I see this quote quite extensively used these days, I would also like to spotlight my friend, the Swedish character Pippi Longstocking here. That is saying something similar actually to her friend Bamse, the world's strongest bear. You probably know him too. If you're very strong, you must also be very kind. And all three of them definitely are on the right track here, right? I would like to start just quickly discussing one of the key central terms in the responsible AI discussion, because it is so central, bias. Fredrik mentioned it, of course, before too. As humans, we constantly use generalizations or biases to be able to select from millions of options around us all the time. Apparently, our brains receive around 11 million pieces of information every second, which without our biases would be absolutely overwhelming to handle. In fact, we can only process around 40 of those details consciously. So in a way, we are walking around in life being more than 99% unconscious, which is pretty weird. And also, of course, a bit concerning, since some of our unconscious biases are prejudices that could be discriminating in a very, very negative way. You are, since most of you are data scientists here, are probably all aware that our biases, including then our prejudices, of course, in fact, easily jump over to the applications we develop. And this is because, of course, machine learning algorithms, a key component of most AI systems today, learn everything they know from the training data. Historical data that is often based on previous manual process. And when we are training our models on this data, they will, just like children, naturally also learn the bias we have been expressing in the data. And in AI business, bias in means a lot more bias out, because it is one thing if one individual makes an unfair or bad decision, but when we're scaling and operationalizing our AI as we are right now, that means that applications can make a lot more decisions every minute. So AI is sort of acting as an amplifier here. And that is of course serious, since a bad prediction is not just a bad prediction, it's also a bad decision, which has a real impact in the real world. And now that we have laid out the groundwork to why this topic is important, I would like to give you some more practical input to the topic. I have for this 4 main bullets or headlines that I would like to share with you, including both practical things we need to do as well as questions we need to ask as we're developing models or assessing the effectiveness of our models. And it's not all about technology, even if we tend to think so as technical people, right? We always need to consider also people and as well as processes in a nice balance. And to start with, we need to communicate and create awareness. We want everyone in the organization to be aware of the importance of responsible AI, including, of course, data ethics also. Preferably, you would formulate your local practical guidelines for responsible AI. And with that, I don't mean coming up with your own rules, but obviously the need to reflect what is proposed by the EU Commission, since that is most likely what will be complying to going forward. But they need to be written in a way so that they work for your organization. Many organizations I've talked to have created like a checklist, maybe not 160 bullets, what it was Fredrik said, but a list that applications need to pass before you start using them in a business context. The important thing here, though, is that you handle them as a key part of your data and AI strategy and not as a document you keep on a shelf somewhere collecting dust. We want the warning bells to automatically ring for everyone if something is not right, no matter where you are in the organization or what role you have in the organization. And secondly, of course, I need to mention we need to consider diversity at every stage of the AI life cycle. I often get the question who should own AI in an organization, and I always answer that it's not the role for one person because it needs to be a team thing, team effort, and this team needs to represent as many aspects of diversity as possible. Diversity in terms of gender and age and knowledge and background and culture and so on, in order to avoid that individual biases are being reflected in the data and then also in the application, since it learns from the data, right? Third, what is probably most important when we put responsible AI into practice is that it can never be an afterthought. You need to have it with you all the way from the beginning. It's certainly not a simple checkbox or an assessment or checklist you do once. It needs to be considered continuously throughout the AI lifecycle, from the initial questions asked to the decisions that comes out on the other end. And for that to happen, it needs to be embedded in the process and enabled, of course, in the AI platform. And this is where we come into the more practical parts. I would like to, in this bullet, which is the largest one, walk you through the AI life cycle to give you an idea of things you would need to look into and some examples of questions you would want to ask yourself along the way here. Let us start here to the left. Which is actually outside of the AI life cycle, because like I said, responsible AI can never be an afterthought. Already when we design and define the project, we need to ask ourselves a number of questions. For instance, does this project align with our own responsible innovation principles, our own policy? And do we have the right data or enough data to accomplish the ask of the project? And does this project comply with GDPR or other legal requirements we need to comply to? And if we can say check on all those, we can enter the actual AI lifecycle. And it is always starting with data, right? Since our machine learning algorithms learn, like I said, everything they know from training data, we need to make sure that this data has the right quality and that it is correct and fair as much as possible, at least already from the start. It is, of course, super important that the training data is representative, like I said, to the intended users. AI tools reflect the bias of those who built them. So if the system is developed by or based on data related only to, for instance, white middle-aged men, then the AI system will automatically be tuned to work better with this group. And that is fine if it's a tool that is meant to be used only by white middle-aged men, but not so cool if it was meant to have a broader scope. And we also need to check for sensitive variables like age and gender and ethnicity, to name a few. This could vary, of course, from industry to industry and from use case to use case. In some cases, it's applicable to use a specific variable, and in some cases, it's certainly not okay to use a very same variable. And to make it even more complex, we should also look for potential proxies for sensitive variables in the training data, which means features that are predictive of the sensitive ones. And finally, in this stage, we want to investigate how the event rate is distributed across different groups. Is it evenly distributed? And most importantly, is this the pattern we want our model to learn? This data comes from a model built for a hypothetical scenario that predicts whether ICU patients that cannot resonate, obviously, around their medical history have previously been diagnosed with diabetes or not. This will then be used together, of course, with other factors to decide a suitable path of treatment while they are at the ICU. And what makes this model relevant for this session is that it has been reported in this hypothetical scenario that it does not perform as well for certain demographics. So this is of course something that we need to look into. To the left, we have the representation in the training data, and we are comparing this to publicly available data from something called the county health ranking data. So there's some US data, right? If we start looking at gender, we see that in the public data, it is 50-50 men, women, and it is equal also in the training data, a bit fewer women. But if we also look at the target diabetes or not diabetes, we can see that it's equal between the both. So this is probably not the problem here. Looking at ethnicity of the patients, we see that in the training data, the Caucasians is a larger group, which corresponds nicely also to the public data, 77 versus 76%. And the other groups are also corresponding quite nicely. The Hispanic group is maybe a bit underrepresented in training data compared to public data. It is hard to see here because it's so small, but it is a little bit. In terms of sensitive variables, that are certainly some in our data that are sensitive, like age and ethnicity. They do not show up in my model though, but we should look into potential proxies for these that maybe do. So in this picture here, we are looking for proxies for ethnicity, and here we are looking closer at the African American type. Among the top 3 variables most predictive of African American type of ethnicity, we find both ICU ID and hospital ID. And it is very well known that zip code often is a good predictor of ethnicity due to the history of segregation, right? And an ID of a hospital or an ICU could certainly be related to that. But they actually do not show up in my model. So here it is probably not an area of concern either. But the second one here with a strange name, D1 SpO2 min, it is a lab result apparently representing minimum blood sugar oxygen saturation. You don't have to remember that. It actually shows up in my model. So that one is a bit of a concern. Some Googling tells us that the way we measure blood oxygen saturation in the ICU is by using this device called pulse oximeter. And it clips onto your finger and it shoots out infrared to assess the color of your blood. And Googling some more, we find that the pulse oximeter does not perform as well for people with, for instance, a darker skin tone. It also does not perform as well for diabetic patients as a whole. So this definitely calls in for many reasons to question the validity of using this variable in my model. It might be the reason to our problems, and we should also discuss it with a subject matter expert, like the clinician in this case. As we move on then to the actual modeling phase, we of course need to assess fairness and bias of our model in order to be able to identify bias outputs as well as to trust something, and also to be able to, at least for me, to take responsibility for something, as well as in some cases also for regulatory reasons, we would want and need to understand how our model arrives at a certain decision, right? We of course then need to assess the accuracy of our model as usual, as we do with all models, but also compare how well it performs for different groups to make sure it does not perform better for some groups than others among the intended users. In terms of interpretability, machine learning algorithms are by definition complex and black boxish. Luckily today we have access to a lot of different tools that can provide us with input on how variables affect the prediction in general on a global level, as well as on a local level for an individual observation. And after me, I have a team from Ericsson coming up to deep dive on this explainability topic as I've understood it. So I'm not going to go deep into that here, but as an example, I would like to show you this plot of shapely values. The blue bars represents the average estimated kernel shape, a bit simplify the contribution from each variable to the output. Here again, for the African-American type of ethnicity, the orange bars look at the same, but for the whole scored population. And the blue bars, they do differ, as you can see in some cases, from the orange ones, both in magnitude and sometimes also in direction. So I would like to ask the clinician what could be the reason to this before deciding whether I should put them in my model or not. Like I said, I would also like to assess the model's accuracy and compare how it looks between the different groups. And here I'm looking at 3 different fit statistics: multi-class log loss, true positive rate, and max KS. And it looks quite good for the Asian group, with close to 100% true positives and close to 1 in KS, which is good, and rather low log loss, which is also good. It looks a little bit worse for the others, though, as you can see. Below, we summarize by looking at the maximum difference between groups for the 3 statistics. And compared to, for instance, gender to the right, we have quite large differences in performance between the different ethnic groups. Here we're instead looking at the average probability for a predicted event for each of the different ethnic groups. And apparently the highest average probability for previous diabetes diagnosis are found for Native Americans and African Americans, and the lowest for Asians. And the maximum prediction difference between the groups can, in the same way as in the previous slide, be displayed like this, where we see that ethnicity has quite a large prediction difference between groups compared to, for instance, gender. And the larger the difference in these 2 last slides, the more potential bias in the model. It might be even easier to understand if we imagine that this was the probability, for instance, getting a loan approved. And if the differences between groups were this high, it would have been pretty unfair. So this is not so good. And it is at least a warning sign that you should reconsider the data used in your modeling process overall. As we then move on into deployment and start using our models in a business context, we need to continuously monitor model outputs and accuracy and decisions also over time. And we need to be notified, alerted here when we need to update or even replace models to make sure that the application continues to perform as intended also over time. The world is not stationary, right? We have experienced that, all of us, over the last 2 years, and models quickly decay, even under normal circumstances. And if we do not have model management and a good governance framework in place, they will result in weird and wrong decisions, right? False decisions. If we're not successful in this phase, we will simply be driving decisions based on models that no longer correspond to the world we live in, models that are causing incorrect decisions, and after a while, people will lose trust to these outputs, of course, or maybe even much worse, they will trust them when they're in fact not accurate, which is also bad. We want to be able to monitor things like, for instance, input variables, distribution over time, and also, of course, output variable stability over time. And We also would like to look into, of course, prediction accuracy over time, like lift curves and drop curves and whatever we prefer using, and also feature contribution over time, among other things, of course, and decisions, how they look over time, of course, also. These screenshots are from another project, as you can see, because the diabetes models had some obvious issues, as we outlined, so didn't make it this far. To wrap this up, I would finally like to give you my number 4 of the 4 bullets. And it is important that we remember that also Fredrik said in the end that even if we make sure that we have good systems in place, we always need to keep humans in the loop, because it's not humans or machines, right? It is really taking both. We need to team up with and work alongside the machines in order to be successful. And together, in synergy with the machines, we can build really, really strong teams that can operationalize and that can scale responsible AI, and together build both business impact and trust in systems that can hopefully also react fast and correct in weird times like this during an ongoing pandemic. So thank you so much for having me and for listening today. And I think we have time maybe for one question, I don't know, but otherwise feel free to connect and contact me with questions afterwards. Thank you.
Okay, thank you very much for that, Josefin. That was great. Yeah, so we got you really showed on a mixed level how many layers there is to this. It's not just like you can do one thing, you follow this simple step, and then it's implemented. There are like the errors can pop up from everywhere, so it's quite difficult actually. And if let me see on your questions, you can see that. Well, they're on fire. You have a lot of questions as well. So but we'll try with one. We'll try with one now, and then hopefully afterwards, maybe we can. And
I'll
again,
stay.
Great. The audience will appreciate that. But we'll give you one. So you talked a lot about. You mentioned the importance of communication and creating awareness, and of course, it is the problem here with operationalizing AI. It's not just technical, but much of it is. Much of it is technical, as you've shown here. And it can never be an afterthought, as well as you said. So one of the questions we have here is, let's see what it says here. It says, how do I, as a data scientist, establish buy-in from business leaders to start to implement what you're talking about here? But we see there are many steps here. And when you're actually, this is a very good, like clear from an academic point of view, but if you go out to industry, maybe the business leaders, oftentimes they don't know what this is.
No.
They don't quite understand why they need to prioritize this. So if you're in that situation, what are your tips? Where do you start?
I mean, of course, like I say, create awareness, talk about what could go wrong if I don't do this. I mean, and up until now or up until soon, you know, we have been ahead of regulations, right? So then we just need to show what could go wrong, and we can talk about how we lose trust from our customers, we destroy our reputation when we're making false decisions, and those are things that they listen to. But I mean, it's pretty sad, but actually, even we of course need to continue to communicate, but of course also, I mean, it's not until it is about money that they actually start listening. And I mean, now if we get this regulation taking place, there's also fines involved, right? They have to pay, it's a 6% of your global annual revenue if you're, you know, breaking the regulations, whatever you say in English. So that's one thing, when you know that it has a business impact to not have these things in place. But I mean, talking about what can actually happen, losing trust and hurting someone, and then the economic part, I think those together are probably efficient.
Yes.
I think it's a good idea to use your marketing team if it's a larger company, and to help you communicate and make everyone aware of how we
fix that. Yeah, that sounds very reasonable, Josefin. So in a sense, try to translate it at this stage, at least. We'll see when AI will be more, the maturity in the bigger populace will grow over time. But right now, maybe the best one of the options is to talk in terms of revenue and the potential risk to our customer base. And also, maybe we don't talk about that negatively, but also do it as sort of like a marketing thing where we talk about what we're doing and create that trust in the target demographics. That sounds very good, actually.
But I see, the fact that there is actually a proposal of regulation, just that fact that we have a proposal makes us, jump higher up on the agenda within the organization. So we can get some good help from that. The things that Fredrik talked about. Yeah.
There was a question about that new AI Act. Hopefully we'll take that at the end.
Yep.
Thank you very much, Josefin.
Thank you.
All right. So great. Now we'll reach the part where we're gonna have the pleasure to hear from an excellent quartet from Ericsson. We have 4 researchers, all very credentialed. They're gonna talk a little bit more about more practical side of things. And a bit more about explainability and safety and how they solve that at Ericsson. So with that, I think it's Kristijonas, you're probably going to start up. So the stage is yours.
Thanks very much, Ali, for the kind introduction. Just confirming that you can all well hear me and see the slides.
Yes. Yes.
Thank you. So hi all, this is Ericsson Trustworthy AI research team. Here, Kristijonas, my colleagues Alex and Alessandro are on the call. They will give some part of this presentation as well. And we have Swarup, Mohalik, who is part of the team. Just would like to thank the audience for being here. It's a great pleasure and honor to be here and present this and then talk about Trustworthy AI from explainability and safety perspective. And thank the organizers as well and the other speakers. Speaking about the other speakers, the great talks that we heard already, fascinating, very relatable, and especially thanks to Fredrik, I don't need to say any more about Trustworthy AI from the point of view of European Commission's ethical guidelines and so on. I will jump right into it, and I will say that this talk will focus on the aspects of explainability and safety of AI, the technical aspects, and our work at Ericsson on those. So first of all, we start with explainable AI. Just would like to say that generally, explainable AI is a hot topic in AI and in society. There's plenty of academic activity. So top AI conferences have lots of publications, lots of workshops and other events dedicated to explainable AI and explainability. Industry, plenty of action going on there, both the startups as well as big technology companies putting down white papers on explainable AI and so on, as well as within society, reports and programs, and this is ever growing kind of material. So with that, having that explainability is a big thing within AI. I would just like to say what roughly explainable AI amounts to, following Fredrik's words already. So in principle, it is about making AI systems intelligible to their users, be those users humans or machines, actually. So in principle, explainable AI comprises interdisciplinary research from AI, from computing, as well as psychology, philosophy, social sciences, and so on. So it's a really wide-ranging field. And principally, one of the goals or the main goal of explainable AI is that of providing explanations behind the decisions or recommendation of the systems in order to make them trustworthy, in particular to us, to humans. Now, we have already heard a little bit about the interpretable machine learning here, and in the public space, explainability is often dominated by the black box problems of machine learning and statistical numerical techniques. I would just like to put forward to the audience that it's not explainability, it's not only about machine learning, it's also about machine reasoning. So various other symbolic and hybrid reasoning, logic-based techniques, and so on. And it is really important aspect aspect of that. And arguably, it has started a very long ago, starting with the early AI systems. I would say, 4 decades already we have of explainability research with waves, going in this sense. Currently, the wave is on black box machine learning models, but in principle, it's about AI in general. So given that explainability is about AI in general, I would just like to say what we mean when we say that an AI system has to be explainable. So we postulate that an explainable AI system has to produce details and reasons underlying its functioning and its outputs. So I know this is a very high level, but the high level picture is that we have an AI system that consumes inputs or queries from data or knowledge, and then produces some outputs or answers to a user of that AI system, be they the user human or a machine. And in order to make the system explainable, we envision typically a component that is called often an explainer component that explains this AI system. So it can be part of the system itself. And normally, so it provides an explanation to the user about the functioning and outputs of the system by consuming the internals and inputs and outputs or anything else that is relevant for that explanation. Typically, it also provides the explanation to some implicit question about the AI system. Why this prediction? Why not something else? Why not other recommendation? How do I make something better? How do I achieve something? So that the user of the AI system can consume explanation and act after the explanation, maybe in debugging the system, making it better, or simply maybe in forming trust in the system. We'd just like to very briefly illustrate in a telecommunication kind of example where explainability comes in. So we can imagine that video services are running over mobile networks, and those are, the video service is running on the physical network, meaning that there are servers, routers, antennas, base stations, and so on, which put the signal to the video stream to your phone or your mobile device, and so on. And that is typically, managed using AI methodology in there, whereby we may want to predict how the traffic of the mobile devices, will increase or will change, and whether that will result into some problems in our video stream, for instance, streaming that, some latency or quality issues or something. When we do that, we may want to diagnose the root causes of that issue. Maybe there is congestion somewhere in a particular router or something like that. Once we do that, or we preemptively do that, we want to re-optimize the system, reconfigure so that we can serve the video to the users at a good quality. So this is all just, standard AI, let's say. There are explainability questions that may arise in each of those, steps in this process. So for instance, if we have machine learning models that are predicting that the traffic will increase by measuring some counters in the network, maybe seeing that lots of devices are connecting in a particular area, we can ask questions, where does this prediction come from? Why do you predict that? What are the most important features? And we have already seen Josefin talking about the kind of, attribution to features which influence the most the outcome. And so these are the kind of explanations that can be provided, called attributive explanations, typically for machine learning systems, that say this feature, maybe this many users connecting here, is the most important in providing this prediction. Some other features are less important towards that. So those are kind of attributive explanations in machine learning that are possible already, and we have seen examples as well. I will not go into many more details. Now, once we have that, we can go into diagnosing the root causes. So suppose we know that the prediction something is going to happen, and we know some facts about it, maybe from the explanations that many users are connecting somewhere. We can then use rule-based systems that use the domain knowledge as well as rules to infer the root causes, maybe a congestion in a particular router, and then For there, we can ask for explanations as to why this particular conclusion rather than some other conclusion. And we can provide attributive explanations that trace the rules and point to the domain knowledge and other facts that lead to this conclusion, but not some other conclusion. So those are explanations in machine reasoning techniques. And finally, I would like to just briefly point to the so-called actionable explanations, those that help to reconfigure the system so that we achieve a more desirable result. If we are pointed out to a reason that there is a congestion due to a particular port, for instance, in the network that does not allow us to serve the video stream, we can use constraint satisfaction techniques or other AI methods to actually reconfigure the system. And we can ask, why can you not configure the system with this constraint, and whether we would be able to serve the video if some constraints were relaxed. In other words, can you give me some suggestions as to how to modify the system, maybe to say that I allow for a bit more latency or something like that, so that I would be able to serve the video stream. And these are the explanations that the system, the explainer would provide to us in order to improve something, to action on those. And I would like to give to my colleague Alessandro at this point to go into a little bit more details into this particular technique. Sandro?
Hello, hi, yes, I'm Alessandro, a colleague of Kristijonas at Ericsson Research. So in this part of the talk, I want to introduce the topic of analysis of inconsistency. And I will also show how this relates briefly to the more general topic of explainable AI. Although some of this concept and technique can be used in the context of machine learning, we'll talk more about the context of machine reasoning. And in particular, we'll focus on this, we start with this simple example using a set of linear constraints. So we start by saying that by inconsistent system or infeasible system, we mean a system that has no solution. So in the example here, we can see that we have 4 constraints, but we can see that the second and the third, so x greater than equal 3 and y greater than equal 3, are, if we satisfy this, then we cannot satisfy anymore the first constraints, since x plus y is already greater than 5. In this context, when something is infeasible, we would like to have an explanation. So we would like to have a reason of why this is the case, and also a relaxation that can help us to repair this inconsistency. So in this context, yes, thank you. Next one, yeah, this one, correct. So in this context, we can define 2 concepts. The one is of minimal explanation, which is a minimal subset of constraints, which is still unsatisfiable. So here we can see the previous example in which there are 4 constraints, but if one looks more carefully, just 3 of them are really involved in the conflict and are causing this infeasibility. Actually, the 4th one is not participating at all. There is also the concept of minimal relaxation or diagnosis, which is a minimal subset of constraints to remove in order to restore the consistency. So here we can see an example, again, the same example, and we can see that if we remove the 3rd constraint, so y greater than equal 3, then the system becomes feasible again. Notice that, of course, this is a small example, but the constraints that are involved in a real-world problem can be huge. It can be a huge number, and the conflict can involve just a few of them. So it's important to report just the smallest number. Intuitively, just to give you a hint of why this relates to the more general concept of explainability, this can be maybe easily seen when it comes to the question of why not, since why not somehow implies a form of impossibility and as such a lack of solution. So we have a few questions here, like why can't satisfy my preferences, if, for example, a user has expressed some of them, or why there is no better solution, for example. Next one. So here we introduce the problem of interactive product configuration, where a user is faced with the task of choosing among options, each with its own requirements and the constraints, and that are potentially conflicting among each other. The user can choose a configuration or express some preferences. And we can see on the right, there is this tool, which is the feasibility checker, which has a formal representation of those options and the relationship, where a formal representation is a set of constraints or logical statements. And the idea is that the user send this configuration or preference to the feasibility checker, which is responsible to check whether the configuration is valid or the preferences are expressed that are expressed by the user are compatible. If this is the case, so if the configuration is valid or the preferences are compatible, then the answer, the positive answer is returned to the user and the process ends here. Otherwise, in case of negative outcome, this is reported to the explainer. Next slide. So in this case, the configuration is, we are already in the situation where the configuration is infeasible, and the explainer is the tool that is responsible to report an explanation to the user. Since not all the constraints or user choices are involved in the conflict, it's important that for the explainer to report a minimal set of them that are actually causing it, so that the user can focus on the part that really matter. And also, another possible support that the explainer can offer is to report a minimal set of user choices that have to be changed, or report the set of constraints that encode the product configuration problem that can be relaxed if possible, so that the feasibility of the system can be restored. With this is all with this part, and we can go to the next one, which is Safe RL, and will be presented by Alexandros.
Hello, everyone. Thank you for inviting us, and thanks also to the participants for being here. I'm Alex, and I will present the second part of this presentation, which is the symbolic safe reinforcement learning. So what is symbolic reinforcement learning? So we know that reinforcement learning is the branch of machine learning that deals with the problem of controlling dynamical systems under uncertainty over time. And we would like to control the system in order to optimize the performance, usually given by reward functions. But sometimes in different applications, we want to improve the dynamical system with by controlling it with more complex specification, which in general, they cannot be automatically translated into rewards, or it's not straightforward, or it can require reward engineering. So the question that arises here is like, how can this complex task be assigned or imposed to that system? And here it comes the ideas of formal methods and machine reasoning that Chris has already mentioned. And we use model checking techniques in order to have formal guarantees of this satisfaction and explanations. So that's actually the symbolic reinforcement learning, the field that bridges this towards the world of traditional reinforcement learning and the world of formal methods in order to provide guarantees and explanations of how can control the dynamical system under these tasks. And why we are interested in that? We're interested in that because these tasks arise in different applications. For example, industrial, robotics, and autonomous cars and telecom. We will show later as a small use case. So how this framework actually works. So we start by having a model of the uncertain dynamics into a Markov decision process. It's a discrete model actually that can model almost all systems in nature. It has states, actions, transition probability matrices, and rewards. So then we can assign the dynamic RL agent a desired task that we, the users, want the agent to learn and satisfy that task with some guarantees. So we need to have a way to convert these tasks to so the system understands it. The system is represented into a discrete model, which is an MDP. Then one way to express this task also in something that the system can understand is the representation into discrete models, such as automata. It's one way of it, or other mathematical formalisms also. There are different ways that someone can do that here. One way, for example, is temporal logics. That's popular or other optimization approaches also. So the idea is by matching these two, the task that is translated into a discrete system, then we can apply formal methods, techniques, and model checking, and then we can have some guarantees of a system that will satisfy or not a given task. Sometimes it can be tasks that the system cannot reach. And these are usually probabilistic guarantees. So we have high probability that the task will be satisfied by the autonomous agent. And now we will see a small use case to it, to what we have applied in Ericsson. So we can see here, we have a wireless mobile network, typically consists of a geographical area that is partitioned over cells. And then we have a base station, radio base stations, which are actually towers with antennas. And these antennas are providing connectivity to all of us and our devices. For example, our phones, our laptops, our cars, etc. So if we zoom in each of these towers, we can see that there are antennas that, according to how the traffic evolves, then we can control those antennas in order to be tilted appropriately, in order to have some guarantees for the network. And usually guarantees in the networks are some performance indicators. For example, capacity, signal quality, coverage, etc. So in order to have good user experience, a good network, we need to control these antennas, these stations, in order to provide the task that we want. So then we have both simulators and real data, so which we can train the agent in order to learn the task, and then we can assign tasks, which tasks are based on these KPIs in predefined bounds. And then by guarantee that the agents are learning optimal actions that keep the network on these predefined bounds, then we can guarantee good quality of the network and user experience. So that's an approach that has been used, and it's suitable for applying these techniques into realistic scenarios. The framework is general, also can be applied to different use cases, because as we said, the MVP is general setting and also the formal methods. And in order for someone to get a deeper dive on how these approaches are implemented their work, we have also user interfaces that the user or a customer can see, can go to specific areas, can see how the antennas are tilted, and it can see how the Markov decision process is built, and it can see what we mean by guaranteeing performance, etc. So that's the idea of this approach. And the last slide, if someone, that was a short introduction of it. If someone needs more details or wants to read more technical, there's publications that we have published, both us and others. So with that, I would like to conclude, and thank you all for listening.
And thank you for sharing that with us. That was very interesting. Very interesting. I have some friends who are, well, they work with IoT and they know everything about these networks and stuff. I'm in a chat with them, and that's all they talk about. And most of the time I'm just like, okay guys, just stop spamming me. But I think they will be very interested in hearing about your application there. So thank you for telling us about what you do with explainable AI. It's a very interesting topic, and I'm happy to see that large parts, in my opinion, of my understanding at least of what I've seen, the AI technical community is aware of it and is moving towards it. Or very. I mean, it's not very difficult really. You can with easy methods gain very much. So yeah, that's really cool. If we look at the questions here, of course, our team is on fire again. We have a lot of questions, but let's start with one before we jump into the panel here. So as we know, there's this other problem sometimes. If you look at explainable AI guidelines, oftentimes they say try with transparent models, with simple models. That will give you, if you want to understand what your system is doing, try with simple models. But as we know as well, some feature spaces in certain problems or in many problems are not what you say interpolative. So we are forced to kind of use more advanced learners. And with that said, the question reads, yeah. So when it comes to explainable AI, we rather choose more simple models, but as we venture into more complex models, applied to more well, complex feature spaces, what should we consider then?
I may try to take this question. I mean, if that's the question, that was the end of the question. I would just say that, okay, even though the AI models do get complex, I think we should not be afraid of that and should work appropriately with complex AI models and strive for formal guarantees. And Fredrik already mentioned that, formal guarantees not only to the performance, robustness, safety. Alex in this talk showed us, formal guarantees of safety. So you can, even though the models are very complex, you can still ensure safety of those by using formal reasoning techniques in there. Likewise, for explainability, look for measures of explainability, the goodness of explanations, and so on and so on. And the more complex you get, if you really need to use a complex model in principle for making more, more accurate models and so on and so on, better ones, you should work harder on the equivalent formal guarantees for those, so that you can ensure that they're trustworthy. That would be my brief take on that.
Yeah, very interesting. So a follow-up there perhaps is, there was another question where it says, when it comes to correlation versus causation, the more complex it gets, the more difficult it's going to be to deduce causality. What is the how important is that in your organization, deducing causality? Because I saw they put up, you had a slide where it says SHAP values, for example. So yeah.
Briefly, crucial. So of course, striving for causality, and we're working on that as well. We did not present that, but we strive for models where we can identify some form of causality. Sometimes it is easier in machine reasoning of formal approaches that are logic-based. Alessandro talked about, constraint satisfaction problems. You have that well formulated, what causes what, how that works. That's one idea. But also when you're working with statistical approaches, there are ways of approaching causality in principle, not only for probabilistic models in general, as we saw mentioned by Perl's, Fredrik mentioned Perl's book, on the book on why and so on, but also, using correlational techniques to infer some form of causality and see whether it actually responds to that. Even if one is using some analysis for explainability, such as Shapley values, that theoretically do have nice guarantees, but in practice do not perform as well, one can still perform some causality studies on that and see whether those are actually performant. But importantly, one would be looking for formal guarantees that the actions of the system or the explanations or whatever other measures are actually causal or represent some mechanistic a relationship rather than just statistical correlation. That is not always easy, we do admit, but for Ericsson, I think it is a crucial approach. You can, like for many others, yes, you cannot just simply rely on statistical approaches. You really need to look into that for sure.
Thank you for that answer. Very reasonable. With that, thank you to the Ericsson team for your talk. It was we had a very good, I think, high-level AI regulation, and then get more operationalized with Josefin, and then the Ericsson team, which shows us, very specific examples. That was very good. Thank you.
Thank you very much for your attention. Thanks to the team and the others. Hopefully
you can stay for a few more minutes, and we can. I'm thinking we have a couple of questions for everyone. We can start with one more for each team here, and then we'll see. We'll take it from there. Hope it's okay. So let's start with Fredrik then. Which one to choose? Okay. So I found one here. Give me 1 second. Oh, here we go. Okay, there's one that is asking about the discrepancy in the approach between different regions. Say, it can even be EU and yeah, Asia, America. So, how does that look? Just on a high level, what are the? Can we see the approaches different regions are taking? And how to look for Europe compared to the rest of the world?
So definitely, I mean, there are definitely kind of regional differences, but I also think there is also a trend towards some form of convergence. I mean, we saw, I mean, that Europe was first with GDPR. We see now that the US and China and so on are also introducing similar regulations. So I mean, over time, I expect that we will see greater harmonization between the different approaches. I would say at the moment, at least, it's to a large degree Europe that's pushing this. But I mean, as I always say, I think it's kind of I mean, you cannot be leading in regulation unless you're also leading in innovation and research. So I really think this needs to go hand in hand. So I mean, because when you do the research, you realize what can be done. I mean, what are the real problems? Because I think sometimes there is this kind of view. I mean, in some sense, you making up problems that might not necessarily be that important in reality. Extremely rare cases and so on. But when it comes to the European regulation, I think it's also important to be aware that this applies even if it's been developed somewhere else. So it's not like you can buy a solution that's been developed in outside the EU regulation and then say, oh, but then it's the regulation still applies to that system. So I do think that kind of constructions probably will speed up this harmonization. But I really think the key here is to couple regulation with innovation.
Makes sense. I'm very interested in the fact that you mentioned that we're approaching sort of convergence, because sometimes it feels like we're not.
I mean, it's a process over time. I mean, for example, there is this OECD. They are working on their principles, and I mean, I think they had like 95 countries or something like that signed their approach to this. We have World Economic Forum that's also pushing these kind of aspects. So there is a lot of these, I would say, really global organizations that are pushing this. So I do think that, and of course, I mean, we as researchers are very international, and of course, the major companies are also global. So I think there's a lot of factors that kind of pushes things towards harmonization. But of course, I mean, it will take time, and there will be friction on the road.
Thank you, Fredrik. So if we jump to Josefin then. Here's one that is, I think, on many people's minds, maybe bolstered by, entertainment industry, but it's still a valid question, I think. Do you think that an AI system would be able to take better decisions than political leaders? And if so, how would that look?
That's a good question. I mean, first of all, it always learns from data, right? So it needs to be good decisions taken by politicians that the model can learn from. And I think Fredrik was talking about it a bit in his talk. We wouldn't maybe know if it was a better, because it might be a completely not logical decision that the AI took, but might in the end turn out better. But we wouldn't know, right? That's kind of how you said, Fredrik, right? But in the end, I mean, it depends on the training data we have. It can't just come up with its own decisions, basically.
If I'm allowed to add to this, I think this is a really great question, and I would say that this is a question where I mean my take on this is that I think the politicians should make the decisions, However, I think part of the kind of material to make this decision on should be using AI to extrapolate and predict what is likely to occur. So, I mean, one thing that kind of frustrates me with political decisions in many situations is that they claim that, oh, we will do this thing in order to achieve this objective. And at least to me, it's kind of, it seems very obvious that decision will not lead to that consequence. And I think that what is something I would raise is kind of consequence analysis. So, okay, you claim to make this decision in this kind of context, then we can predict what will actually happen. And then do you still think this is a good decision? And then I think the politicians will have a much better sense of making the decisions based not only on, what should we say, the whim, but also on some kind of statistical and an analysis of these potential or likely consequences.
Like such decision support, I mean, AI and people together, like was said before.
Because I mean, I think we have a choice here. So the thing is that the future is not determined. So I mean, I think these kind of AI systems and these kind of automated systems, they're very good when you have a very clear objective. And now it's just a matter of how should we optimize these millions of parameters in order to get the best possible outcome within this very kind of well-defined area. But I think from our politician point of view, it's basically creating the future and or kind of making compromises between many people's opinions and so on. And I mean, if you can actually look at computational social choice, and I mean, there you can study, for example, voting mechanisms. And there is this interesting Condorcet's paradox, which basically says that in every voting system, it's always possible to get an outcome that it's not preferred by a majority. So basically, there is always a better choice if we kind of aggregate people's opinions. But due to the way that the voting is constructed, you will not find that solution. So basically, every voting system is flawed. I mean, it's kind of one way of interpreting this. But still, of course, we need to aggregate people's preferences. We still need to make decisions. And there, I think the politicians have an important role to play.
For sure. That's very interesting concept you to mention. It feels like politics is getting more, closer to people. We have a lot of people that are more passionate about it now, for better and worse. But maybe if we have a system where, our political leaders, when they're taking decisions, there's a system that can analyze that decision and show different outcomes. If that were transparent to the public, it would be very interesting to see. Sort of like if we can use the system to sort of lead to a more transparency in our politics. That would be very interesting.
Definitely.
Indeed. Thank you.
It's a fact checking, not fact of the history, but in some sense, fact checking the future, or of course, we don't know the future, but is this a reasonable consequence of these decisions or not? Yes,
exactly. And that in turn, maybe can lead to more trust in the politics as well, because there's always people that criticize. It's very difficult. But if there's a common ground, like, okay, we're going to take this decision and it can lead, we hope it leads to this outcome here. And maybe we can get more, less divisiveness in the future. All right. Thank you for that. Very interesting. So for the Ericsson team then, I have one here for you. The systems you're talking about, the explanation systems, do they apply on a model-based, or are they applied on the whole system? Is there any hierarchy?
Okay, good question. It kind of depends. If I understood the question, so I understood it in the way that suppose you have multiple systems that are interacting, like in the use case that I described, and you have explainability in each of those, and what is the interaction there. So two points there to say. Good question, by the way. First of all, there is interaction between explainability, using explainability between the different systems and different types of systems, for instance, machine learning and machine reasoning, whereby explanations from a machine learning explainer are consumed by a machine reasoning system for further reasoning. Similarly, explanations from a machine reasoning system are consumed for another system in the hierarchy to do something in there. So there is that kind of interaction. On the other hand, there might be, you might be thinking about the hierarchy in a different sense, where you somehow have a different layers, low-level system of system AI models or methods that are doing something with the network parameters and so on. Then at a higher level, you have a little bit higher level view where you have the overall orchestration of those systems. Even at a higher level, you have the the very kind of auditing view, or just overall overview of the system in different terms. And then there would be, the question would be about explainability from the low level coming to the high level, then to to developers, to users, to then to CEO in the end, and so on and so on. Right, at that level, this is more complicated. So this is something that we're striving at. I had a slide, but I didn't show it, how we plan to build up these kind of systems. This is far from a trivial problem, in the sense that you need to go different levels of abstraction for different personas, and if there are human personas, people who are consuming those explanations, and how can they react to those and feedback back to other layers. So in principle, that is something that is envisaged. I haven't seen myself any of those kind of systems already in place anywhere. So this is again a research for us. This is a research on the research agenda, if I understood the question correctly. If not, please ask on the chat. I can try to clarify.
And of course, you can connect with all of our speakers as well. So keep the discussion going. I mean, we can see, I just saw behind here on, if you're listening here, please join this Slido, where you can go in and give us a survey of how we're doing. And I saw one of the mentions there was, there we go, more people discussing AI ethics. So a bigger event than this might be of interest. I mean, that is a given. This is a starting point. We just touched upon 3 different levels, and there's so much more to this. So we really hope that in the near term we can, just let us know what you want to hear more of, and we hope that in the near term we can delve deeper into the details of what we spoke about today. That is our plan, and it looks like someone said business here. Maybe, yeah, we'll see what that means. And there were so many more questions as well. We don't have time to go through them all, but indeed, this is not a surprise. There's a huge interest in this field, and we're very thankful for the speakers for coming here. It has been of great interest, and we hope that you'll come back to us in maybe even in a physical format in one of our physical AI summits, hopefully soon. Those are usually packed. We have, I forgot to mention at the beginning, there's an average of 120 people at each one, and the tickets sell out like this. So yeah, we're really looking forward to that. So with that, I think, again, just go into the Slido and give your thoughts about the event. And let's give a big digital round of applause to our speakers. So everyone's here in the talk, unmute and give yourselves a round of applause, and thank them in the chat. Yeah, and we'll see you next time. Thank you very much for tonight.
Thank you, Ali. I would like to thank the organizers very much for this. This was a great pleasure. Thank you.
Thank you.
Thank you.
Thanks,
Thank you so much.
as well.
Thank you all.
Thank you. Thank you all.
Thank you all.
Have a good evening then.
Yes, likewise.
Bye-bye.
Bye.
Bye-bye.
Is anyone there?
No.